Good morning, everyone. I hope you had a great evening last night. Welcome to Microsoft Ignite, to the day 2 of the event. And my name is Bhanu Prakash, and I am a senior program manager in the Azure Databricks team. So before I get started, I just want to get a show of hands of how many of you here are data engineers. OK. And how many of you here are data scientists? OK. So today, I know it's a little challenging to create a data pipeline, especially with big data, structured data, semi-structured data. And today, we will show you how easy it is to create that big data pipeline, a robust pipeline, a consistent pipeline, which is simple and easy to use and can be reused for different scenarios. As you know, data has been a key strategic asset in any of the activities you do, whether you do online shopping or whether you do purchases or you go to a retail store. Data is tracked everywhere. And organizations have been making use of data to take decisions, to bring a new business model, or to stay ahead in the competition. So it is no longer a hype. Big data has been there, and organizations have been trying to make use of data in all possible ways. In fact, if you look at the statistics, according to IDC a couple of years ago, the combined value generated, specifically focusing on the task for data engineering and data analytics, organizations have been able to generate $1.6 trillion. And you wouldn't be surprised because these numbers are 2 years old. But still, if you see, like 10% of the world organizations have been focused on just doing data engineering and data analytics activities. And the combined value, like each of these organizations have been able to generate like $100 million, again, according to Keystone back 2 years ago. So we all understand that data is no more a hype. Like we have been playing with data more than last few decades, and now with big data and all the exploration and enhancement with AI and different technologies that is coming in, it's adding lots and lots of value. In fact, let's take an example of how Chevron is able to use data in their to do some prediction using big data. So let's go ahead and take a look.
All of them are working tirelessly to help those communities and people deliver the energy that enables human progress. Partnerships are a core business value for Chevron. At the heart of all of that is our vision to be the global energy company most admired for people, partnerships, and performance. So we strategically look for partners who share those values. In October last year, we signed with Microsoft as the premier cloud supplier for Chevron, and we've had a long-standing partnership with Emerson. The aim is to leverage their technical solutions to answer our business problems and succeed together.
Emerson provides complete automation solutions. We provide sensors, control valves, control systems, optimization software that helps those plants run safely and to their optimum production. When it came to working with Chevron, Microsoft was a natural choice because they've built a lot of great technology into Azure, specifically targeted industrial IoT. Chevron had a lot of sensors and a lot of data around controlling their facilities, but needed a lot more data on reliability and energy consumption. That's where the Plant Web Digital Ecosystem comes into play.
For our first pilot with Emerson and Microsoft, we used Emerson sensors and gateways to connect the data from the field to Microsoft Azure to allow us to perform the analytics. Supplementing data from our control system with the IoT information provides a much richer data set, which we can now use to optimize our entire value chain. Within Chevron, we've got more than 5,000.
So as you noticed in this video, it's not just with Chevron. It's across the industries, whether it's manufacturing, whether it's healthcare, whether it's genomics, whether it's banking. Everywhere there is usage of data to create new business models. If you talk about healthcare, like it has been AI and the data has been used to cure the treatments of diseases or any specific things like creating new drugs effectively or treat cancer. Or if you talk about banking, to detect the frauds, it's all about data. If you think about IoT, in the case of Chevron, as you noticed, the streams of data has been coming through the IoT sensors, which is combined with the existing batch data to do some analysis and prevent the outage of our equipment. And similarly, whether it's education, retail, e-commerce, data has been used, and it is how the organizations have been spending money and time to make use of data through the technologies available. Now, in the next 60 minutes or 65 minutes, we will walk through in terms of what are the challenges that you would be seeing while creating these data pipelines, and how, when you go back, how these technologies which are available on Azure will help you to simplify those issues and create and make ease, and will help you to create these data pipelines in an easy manner, right? So why is, first of all, data engineering hard? We all understand that data has its own value. You can make meaning. You can create business values. But data engineering is not easy. It's not easy because data is not coming from one source. You will have data in multiple sources. You have data on your on-premises. You have data on cloud, on-premises. You have data in different systems. And then there is also a schema mismatch. It's not just data available in JSON. Like if you think about real-time data, the schema often changes. If it is JSON format, it can be org format, it can be Parquet format. So data is represented in different ways. If you think about the date time field, the data can be represented in multiple ways. If you think about data, it's also not like all data is not right. Like there is corrupt data, there is corrupt file. And you need to be able to handle that corrupt data and corrupt file. If you think about the data, it's not just structured data. It's unstructured data, semi-structured data. So the scale at which the data is growing is vast. We are talking about petabytes and exabytes of data. The schema also drifts. So especially if you are thinking it's not just batch data, but streaming and real-time data, the schema of the data often changes as it streams in. So you need to be able to have a system to ensure that if the schema changes, your pipeline is still robust and the pipeline is still consistent. You need to have a way to monitor the entire data pipeline. You need to make sure that at every steps in the data pipeline, whether it's ingestion of the data, transformation of the data, or analysis of the data, you are able to monitor this end-to-end. And you as an organization, you want to make sure that, hey, if someone makes some changes to the pipeline, someone accesses the data, you want to make sure you have an audit control system to see who did what. And then as there are different pieces in the whole end-to-end pipeline, you want to have a seamless experience in terms of having a centralized pane of glass to monitor and create these different activities from a single pane of glass. And lastly, you don't want to worry about being able to responsible to manage the infrastructure of these pipelines. Rather, you want to focus on your business problems. You want to focus on how to focus on your business values and the logic rather than managing the infrastructure. So when we think in terms of the data engineering system requirements, it basically boils down to three parts. From a data management perspective, your system needs to be able to handle batch data. Your system needs to be able to handle streaming data. Your system needs to be able to handle schema management if the schema of the data changes. You want to make sure that even if there are multiple readers and writers for the same data, the data is consistent. It provides a consistent view. You want to make sure that the data is secure. You want to make sure that you are able to query the data in a fast manner. Like it should not take hours or days, rather a few seconds or even microseconds to read the data. From a platform perspective, you again have a choice. You want to make sure that, hey, are you going to be responsible for managing this whole end-to-end platform by providing the security, by providing the resource capacity estimation, by providing the upgrade facility, or rather, you want a service where the service itself can ensure that it is always patched, the underlying infrastructure is always upgraded to the latest software available. It has the right tools to be integrated so that you can program the whole end-to-end big data pipeline. Or it is scalable enough so that if your needs change, the infrastructure can handle that scale. Or if your needs go down, the infrastructure can shrink, so you're paying only for what you're using. And it needs to be able to handle the distributed computing to process that vast amount of data. And lastly, as I said, you want to focus on your core business problems rather than managing the infrastructure. So how about a service that is managed for you, and rather than you taking care of the management and spending time on making sure that the service is up and running? So there are two types of data engineering scenarios that we have seen after talking to customers. The first scenario is modern data warehouse for business intelligence. And if we take a look, it starts from data being collected from different sources. You have data coming in from structured system. You have data coming in from unstructured system. You have data available on your on-premises system. You have data available in different clouds. So there are different sources where the data is available. And the first step to establish the data engineering pipeline is you want to move the data or ingest the data into a data lake. And you don't want to go ahead and create different connectors or be responsible for understanding like creating your own connectors. Rather, you want some service that already understands these different systems and can ingest the data from these different systems. And that service in Azure is called Azure Data Factory that can ingest data from 75 plus different sources. So whether it's data in SQL, whether it's data in Oracle, in your CRM systems, it can natively understand 75 plus sources, and it's growing every week. Then you want to land the data in a data lake. So in Azure, you can land the data in Azure Storage, Azure Data Lake Store Generation 2, Azure Data Lake Store. And once the data is landed, then you transform the data. And the way you do the transformation is through Azure Databricks, which is, again, a first-class, fully managed Apache Spark service on Azure. And once the data is transformed and prepped, then you want to make meaning out of the data, and that is where the data is available for your data analyst and the business analyst in a SQL data warehouse, where they can use visualization tools like Power BI to connect to the data warehouse and make meaning out of the data. Now, this is pattern one. And the other pattern is where you want to do advanced analytics for apps. So almost the ingestion part and the transformation parts remain same. But what happens is now you can do some advanced machine learning and create some SaaS apps where you have the transformed data moves to an operational store like Cosmos DB, which can serve as a source for your SaaS apps. So in one example here is Adobe Marketing Cloud, who have been doing the same scenario where the data is ingested from different sources through Azure Data Factory. And once the data gets ingested, they start the transformation activity. And after the transformation is completed, the data moves to operational store to serve the line of business and SaaS apps. And all of this, by the way, end-to-end can be orchestrated through Azure Data Factory. So you don't have to worry about manually keeping an eye and seeing where the data is flowing, what stage it is. All of these can be automated. All of this can be scheduled. All of this can be orchestrated. And in the event, if any of the places it fails, you can get an alert and you can be notified, or the jobs can be retried based on those failures. So what we are going to do, generally what we have done is like, hey, we go through the different topics, and then we have an end-to-end demo, and you have to wait for the whole 60, 75 minutes. In this way, what we are going to do is I'm going to follow a different approach, where I'm going to demonstrate a real customer example in which how the customer is able to establish an end-to-end data pipeline in a simplified manner on Azure. And then we'll go into how this exactly works by talking about the technology part. So let's go ahead and take an example. So in this case, the problem that I'm trying to show here is about an insurance company. The insurance companies, they often receive these claims. And for them, they want to make sure that they are processing the claims pretty quickly and pretty fast so that the customer is happy and ensures like, hey, my claims are approved. And from the insurance company side, they also want to make sure that if there are fraud claims, they are able to detect it in time so that they are not out of the business, right? Like I have personally filed 2 claims in the last 5 years, and at once it was a very happy experience, and at once like it took like months and months to approve the claim, and it was not a good experience. And of course, we understand from an insurance company perspective, like they want to make sure like the claim is valid, it's genuine, and it's not a fraud claim. Now in this case, in this example, the way we do it is the claims company have an existing data set where they know, like based on these parameters, these different values, the policy ID, the details of the claims, this claim is genuine. And then they have newer data set that comes like in a real-time manner or on a batch basis every day, every week, where they want to score that based on this existing data set, they will create a machine learning model, and they will use that machine learning model to predict whether a particular claim is fraudulent or not. Now imagine if you have to do it once, then it is all fine. It can be done manually or through some ways. But imagine for an insurance company which is so big, and especially the data is coming almost every day, and vast majority of claims are there, and so much of money is involved. You don't want to be a business of creating these, spending time on managing the infrastructure to create this, but rather what you want is an end-to-end system that is already available to create this in a scheduled manner so that as and when the newer data set comes, you are able to use a machine learning model to predict that data set, create a newer data set which is available that says like, yes, this claim is fraudulent, this claim is not fraudulent. And then finally, you have this transformed data set that you can now make it available in a relational store so that your analyst or the people who are working on the claims department is able to make decisions based on that. So let's go through this. In this case, I have this data that I was talking about. So let me open this data set. So this is my insurance claims data set. As you see, it has months, age, policy number, and different values. And as you see, there is no predicted data. Like right now, it's just new data set that comes. And I also have an existing data set where I have the values, whether the claim is fraudulent or not, right? So I will use that data set to create a machine learning model. And the way I would create a machine learning model is by using Apache Spark. On Azure, Apache Spark is available through Azure Databricks, which is a first-party fully managed service that enables you to run Spark by having it integrated on the Azure ecosystem. So we'll talk about in detail. But for the purpose of this demo, what I'm trying to do here is I'm just using the data set to create a machine learning model. And as a data scientist, the way you would do it, you would do some ad hoc analysis of the data. You would use some machine learning models like decision tree or linear regression. And then finally, you will evaluate the model. And then you will output the model. So in this case, what I'm doing is my data is available on Azure Storage, which is my data lake. And then I go ahead and do some data exploration. And as I'm doing some data exploration, then finally, I'm able to see how the data is split across. I am doing some visualization right in the notebook on Azure Databricks, and I'm not going outside. I'm seeing all this analysis right on my Databricks notebook. So I'm doing some data processing. And as you see, as I'm going through, I'm also I'm creating this decision tree model, which is also available as a library in Apache Spark that handles machine learning. And I'm now able to measure the error rate and do some model tuning. And finally, I'm able to create a model which is then exported in my local workspace, which of course can be exported in any system. But for the purpose of this demo, I have exported in my local workspace. And now I go ahead and then run this whole end-to-end notebook. Now, of course, I'm not going to create this right here. But as you see, as a data scientist would have spent some time. They don't have to worry about managing the infrastructure. They don't have to worry about ensuring the system is up or not. What they are worrying about is just the logic And that, too, is also available in Spark through the machine learning libraries that are already available. So what I have done is I have attached this notebook to a cluster, which is running Databricks, which is basically Spark. And then this model is being created. So let's go ahead and now come back to the other notebook. Now that I have a model that is created, what I want to do is I want to basically score the newer data set with the model that is created in the previous step, right? So in the previous step, I created the model. And now I will, as the new streams of data comes in, I will load the model and predict whether a claim is fraudulent or not. So the way I do it here is I again connect to my data source. And then as I connect to the data source, I go ahead and display the data frame. So in this case, it is all the values that you are seeing in the newer data set. And this, by the way, does not have whether the claim is fraudulent or not. And then as you see, I load the fraud detection model that I created in the previous notebook, and then I'm scoring it against the newer data set. So this is the newer data set, and then I'm scoring it with the model. And then finally, with Azure Databricks, what we have introduced is the public preview of Azure Databricks Delta, which we'll be again talking in detail as we go through. But basically, the idea of Databricks Delta is it ensures data consistency. It ensures atomic transaction. It ensures that if you have real-time and batch data, it can take care of both in a unified model so that your pipeline is simple enough and can be used with the same set of APIs. So in this case, what I'm doing is instead of creating a Spark table, I'm creating a Delta table and then saving the predicted output into this Delta table. And then I'm doing some optimization so that the performance of the query is faster. And now, what I'm doing here is in this step is as, let's say, I have a newer data that comes in. I want to just update a row of the data. I don't want to go ahead, go back, and then restart my whole pipeline. Rather, I can just update a row on the same data set rather than restarting the whole pipeline. So it has, with this transactional capabilities, I am updating a row in the same data set. And now that I have this data set which is structured, which has some value, I can now go ahead and push this data set to a SQL Data Warehouse, which is a cloud-ready, massively parallel processing SQL Data Warehouse or data warehousing on Azure. So as you see, I am pushing this data directly from Spark to Data Warehouse just by running these steps. So what I'm saying is, hey, this is my connection string. So Databricks runtime, we have built a native connector for a SQL Data Warehouse, so you can do bulk movement of the data from Databricks directly to Data Warehouse. And this is how I'm executing. This is just a simple command where it says, copy this data from Spark table to a Data Warehouse table, and then it will go ahead and move that data. And then once the data is moved, I can use Power BI to connect to it. So let's go ahead and run this. So right now, I will go ahead and connect to my storage. And as you see, if you have used Databricks, what you would see here, while connecting to the storage account, I'm not even specifying my keys to connect to the storage. So it's all secure. What I'm doing here is I'm saving the keys that are used to authenticate to the storage in my Azure Key Vault, so that if I share my notebook with other data scientists, they won't be able to see the keys. Then I go ahead and create this Spark table. I create this data frame. And then I go ahead and display this data frame here. And as you see, it shows these different values available in the newer data set that comes. And finally, I'll go ahead and then run this model. And now, I will go ahead and score the data set with the model that I have imported back into this newer notebook. So I'll go ahead, and once this finishes, I will go ahead and run this. And then finally, we will put this data into a Delta table, as I talked about, right? So Databricks also notebook, as you see, there is an option of run all. But basically, I can go ahead and, as I am creating the notebook as a data engineer, I can go ahead and write this code, and step by step, I can execute it. But basically, at this point, I'm showing that is it ready for it to be operationalized so that my notebook is all clean, and I can go ahead and orchestrate this whole end-to-end flow in a scheduled manner. So as you see, I have been able to update this delta table with this newer record that I got. And then finally, once all this is done, let me go ahead and push this data to a SQL Data Warehouse. So I will go ahead and connect to this storage account. So as part of moving the data from Spark to a SQL Data Warehouse, I use a temporary storage account. And we'll talk into the architecture as we go through slides. But basically, in this step, I'm establishing connection to that storage account. And again, by using the secret keys, which is stored in the SQL Data Warehouse. And this is the data frame that I want to move to SQL Data Warehouse for my analysts to make use of it. So let's go ahead and run this. What I'm doing here is for the purpose of demo. The machine learning model that was created, because you want to input things like vector assembler or a string indexer, which is used as an input to a machine learning model, you want to move a high-value structured data to a SQL Data Warehouse. You don't want to move this vector assembler or other inputs that are used in the machine learning model. So I'm basically dropping that value to create this high-value data. And finally, I will go ahead and then move this data to a SQL Data Warehouse. So I run this command. And what is happening here is all the Spark table or the Delta table that was created, it's now moved to a SQL Data Warehouse, right? So now that my notebook is all running fine, I want to orchestrate this end-to-end, because as an insurance company, what I want to do is I want to make sure that as newer data set comes, I'm able to score the newer data set based on the model, and I'm able to run this on a scheduled basis. So this is where Azure Data Factory comes. So let's go and take a look at Azure Data Factory. Oops. Whoa. What has happened to this view? So Azure Data Factory is a first-party, fully managed data integration service. Let's go ahead and take a look at the view. Okay. All right. So I don't want to scare you with this pipeline, but let's start with a simple pipeline. So in this case, what I'm doing is I have my data in different sources. So in this case, I have data on Amazon S3, and I want to copy that data to Azure Storage. And then once the data is copied, I want to start some transformation activity on my Azure Databricks notebook. And the way you would do is basically you create connections, and these connections are basically establishing for whether your sources are compute or data. And as we talked about, Azure Data Factory, using Azure Data Factory, you can connect to 75 plus different sources. So let's go back and create a new linked service. And as you see, you can scroll down through all the data sources that are supported and which could be used as your source or your destination. And as part of compute, Azure Databricks is also available, through which you can trigger the notebook activity directly from Azure Data Factory. So you don't have to go once, as a data engineer, like once you have got this notebook, you don't have to go to Databricks to orchestrate it. Rather, you can orchestrate it directly from Azure Data Factory. So in this case, even Azure Data Factory as a first-party service, let's say I go ahead and create a linked service for Azure Blob Storage. What you would see here is that you can use managed service identities. So let's say as a data engineer, you don't want to give the secrets for authenticating to Azure Storage. You can just use managed service identity, wherein using managed service identity, Azure Data Factory can authenticate to Azure Blob Storage. So in this case, I have given contributor access for Azure Data Factory service in the storage, and then I will go ahead and use a service endpoint, and then just go ahead and test the connection. And what it will do is, using this managed service identity, it will create these linked service. In this case, as you notice, the connection was successful, and I can just go ahead and create these linked service. And once this linked service is created, then I can use this storage endpoint to act as a source or a destination for my data movement. Similarly, I can go ahead and create link service for Azure Databricks, where I can go ahead and trigger a notebook activity. So let's say if I go back to the pipeline that I was showing, in this case, I'm copying data. As you see, I can see the source. So in this case, the source is S3 object. The destination is Azure Blob Storage. This was the link service that I created. And then I can pass in some parameters or some functions and can specify whether it's a binary copy or a full data copy and some user properties. On the Databricks side, what I can do is, similarly, as I mentioned, that you can create the link service and associate an activity to a pipeline with this linked service. And the way you would do is, here you create the link service, and if you go to the settings, what you can do is you can, once it is connected to an Azure Databricks workspace, you can browse through all the notebooks that your data scientists have created, and you can just select the notebook from here. So in this case, if you go back to my Databricks workspace, these are all the directories, these are all the notebooks that are available. So I don't have to go ahead and copy the URL. As a first-party service, I'm able to browse all the notebooks directly here, and I can go ahead and select a particular notebook, and then I can run that notebook from Azure Data Factory itself. So now that this is created, I can go ahead and, let's say, debug a run to see, like, hey, my pipeline is working fine, and then I can schedule it using trigger. So now that this is available, let's go ahead and take and run the actual pipeline that was created. So let's go ahead and zoom this a little bit. Okay, is it viewable? Okay. So what I'm doing is, in this case, I have this data available on my on-premises system, and this is my on-premises system. So if you see, this is connected to a network share, and all my data, raw data, is landing from some system in this raw data folder on every day. So for the last 10 days, as you see, if I go to my folder, I have this raw folder, and then the newer insurance claims file is available. So I go back to this guy. What I will check is that, hey, I will go ahead and check whether the data set is available in my raw folder for this particular date. And then once the data set is available, I will go ahead and start the copy activity where I'm copying the data from my on-premises to my Azure storage, which is a centralized data lake. And I also want to take my competitor data or my partner data, which is available in a different storage system. So I go ahead and copy the data from S3 to blob storage. And let's say if the data set is not available, I basically fail the pipeline and say, hey, the data set is not available, and notify me, some failure activity. And if the data set is available, then I go ahead and start the transform activity. So in this case, basically, I'll go ahead and trigger the ETL pipeline where I was scoring against the newer data set with the model loaded, and then pushing it into a Delta table and back to a data warehouse. And once the transformation has completed, then I want to move the data to a blob storage, and from blob storage, I'll move the data back to my on-premises because I want to have that processed data in my on-premises system as well. So let's go ahead and do a debug run. So I go ahead and do a debug. So one of the things with Azure Data Factory, what it helps is you can pass in parameters, and you don't have to manually pass it, but for your system, let's say the data is landing in some date format, in some specific formats, you can provide functions where it can go ahead and read those formats, and it can create those folders and specific paths, and that can be passed as parameter to your next set of activity. So in this case, let's say today is 9/25. Let's go ahead and do a run for the previous day. So I'll go ahead and use 23rd. And so the input folder on the blob storage it will create is 923, and it will also create an output folder. This is the claims file. And then I provide my email ID so that once the pipeline succeeds or on failure, it sends me an email that I have set. And then this is the source path that I will create. So I'll start the debug. So right now in the debug also, it's doing an actual run. And as you see, as the run starts, you can monitor this run here directly from Data Factory. So I'm not going outside of Data Factory. I'm just in Data Factory. And as you see, it started the first run. It's checking for the data availability. It's doing a lookup, and this is in progress. And while it is in progress, what I can do is, let's say at some point I'm manually triggering a run, I can go ahead and cancel a run. And now that this step completed, it will go ahead and start the copy activity. And as you see, it started the copy activity. Now, while it's running, let it run, and I can show you some of the other capabilities that you can do with Azure Data Factory. So in this case, you can go ahead and trigger. So let's say you want to have this pipeline run on a schedule basis. You can create a new trigger, and then basically say, like in this case, I have created a trigger which will run this job on a daily basis. But you have the option to create a new trigger and then even go back to a tumbling window. Let's say the data is available for the last 2 months. You can set up a tumbling window, and it can run every day for the last 2 months, and then even start from today for a newer data set. Or you can put it on schedule as well, right? So while it's running, let's go back to the monitoring part of it. We talked about how hard it is to monitor an end-to-end pipeline, and you want to monitor it through some system that notifies you in the event of if a failure happens, or in the event if something goes wrong in the pipeline. So these were the runs that I did in the past, or it was happening on a schedule basis. And as you see, I see this failure, or I see this success notice as well. So I can go ahead and basically drill down into which activities happened. So as you notice, this is a lookup activity, and it has the input as well as the output. Or if you see the retrain model, if I go ahead, it can show me the output. And if you click on this, it will take to the URL of the notebook on the Databricks side that was executed. So this will show you that exact model creation pipeline, model creation notebook that your data scientist created, along with the output for this particular run. So as you see, this is the same notebook that we went through. Now, if I come back here to the pipeline, this is the transform notebook. So again, it gives the link of the URL. And then let's say when you are copying the data from Azure to your on-premises, you can see the activity like, hey, this is your blob storage, and this copies the data back to your on-premises file system. So let's take a look at the run. And it's taking some time to run, but basically for my previous run, let's go back to my on-premises system and go back to my Azure storage where the data was ingested. So if I go back to my Azure storage, what I see here is the folders have been created. So let's take an example for a run that happened on 9/14. And as you see, it has the input folder where the data was first ingested. And then it is the output folder where the process data was available after Databricks ran the transformation activity to predict the model and predict the newer data set. And this is the output data that is available. And the same data set is also available in my on-premises because I orchestrated the system to move the data to my on-premises system. So let's take a look at the notebook, at the Excel, where the process data is available. And this is my process data that I downloaded from storage account or on-premises. And as you see, this is the fraud reported, which clearly predicts whether a particular claim is fraudulent or not. And that way, this can be done every day in an automated manner without you worrying about doing it manually. And now that once the data is available, also in my SQL Data Warehouse, as you would have noticed from the pipeline, that this data set is moving not only to my Azure Blob Storage, but in the notebook, as you would have seen, that I'm moving the data to my Azure SQL Data Warehouse. So let's go ahead and take a look at the notebook. And as you see, the notebook, I am moving the data to a SQL Data Warehouse using the command that was executed as part of this notebook. I can go ahead, connect to my Power BI, and say, hey, connect to a SQL Data Warehouse. And let it load. And this is my SQL Data Warehouse. So I say connect. I authenticate against it. So let's go ahead and use the server. And then now it will go ahead and connect to the data warehouse instance. And this is where, as you see, this was the exact tables that I created as part of moving the data from Spark to data warehouse directly without requiring it to move to a data lake and then moving to data warehouse. Like in this case, it's connected. It's moved directly from Spark to data warehouse. And this is orchestrated through JDBC, but all the movement of the data happens through poly-based technology on the data warehouse side. And because of that, the data movement is much, much, much faster. And similarly, I can go ahead and log into my SMSS Studio, and I can go ahead and then see the results, see the data. So as a business analyst, I no longer have to go ahead and go to the transformation engine. Rather, I'm connecting to my data warehouse account, and I can make decisions, create some visualization charts on my Power BI. So while it's loading, I will go back to my actual presentation and then talk about how each of these different technologies have been making it so easy for you as an end user to create these end-to-end big data pipeline through the different technologies that we'll be talking about in the next 30 minutes. So this brings us to modern data warehousing. As you noticed, it has 3 steps. You first load the data. Once the data is loaded, then you process the data. And once you process the data, then you serve the data and do some analysis. And this is actually prevalent across most of the industries. And as you see, some of the customers, like Ruby Cloud in this example, is exactly doing the same pattern. They are able to load the data, then transform it, and then do some analysis. And they have created this as a platform to the retailer companies, which are their customers, to provide a machine learning platform so that their customer have some insights for the customer activities. Based on that, they can take some actions. If we talk about Carnival Cruises, now they can predict when the equipment needs to have some replacement or have some repair using the same data activity. Or we talk about Reckitt Benckiser, which produces products like Dettol, Lysol. And their sales personals, they want to have a real-time analysis into when a particular SKU is performing well or not performing. And they want to have insights into that. And they are, again, using this modern data warehousing through the different technologies on Azure to make some meaning and derive some insights. Now, let's go ahead and talk about each of the different steps in detail that we went through in the demo. So as a first step, we talk about data ingestion. Data first starts ingestion through Azure Data Factory, which could be your structured data, which could be your unstructured data. And then for unstructured data, you can land it in a data lake. Same you could do for structure, or you can also land the structured data, let's say, in a SQL database. What does it mean for you as what exactly is Azure Data Factory? So as a first-party service on Azure, it's a fully managed data integration service. So as you noticed in the demo, I was able to orchestrate the whole end-to-end pipeline with just click of a UI. And by the way, I can also program it. I can use ARM template, or I can use REST API, I can use PowerShell, and orchestrate the whole end-to-end flow programmatically using APIs. And as we talked about, that your data is available in different sources. It's not just on-premises. It's also on other clouds. It's also on Azure. And you want to establish this hybrid model where the data is available on-premises, data is available on cloud. And what Azure Data Factory provides is the capability where you can have this pipeline in a hybrid model with the data available in different systems, and you can move back and forth from different systems. With 75+ connectors and the fact that it's growing, you don't have to worry about creating different connectors by yourself. Rather, you can use this technology that seamlessly that our engineers have been working to natively connect and help in the faster movement of data natively. And then for those of you who have invested in SSIS packages, what this allows is you can use the same SSIS packages and run it on Azure Data Factory without worrying about underlying infrastructure. And then lastly, you can do all the monitoring of the pipeline end-to-end at ease without worrying about doing a manual monitoring. So let the service monitor the whole end-to-end pipeline for you. Now, if we look at the core of what is Azure Data Factory from an architectural perspective, what we see here is an integration runtime. So if you are moving the data just within Azure, what it will do is it will create this Azure integration runtime, which is the engine or the compute responsible for the actual data movement. and you don't have to worry about creating VMs, loading this software and stuff. It all does it for you. Now, if you are having a scenario where the data movement is from your on-premises to Azure or back and forth, then what you have is a self-hosted integration runtime, and that allows for the data movement in a hybrid model. And it is all secure. You can create an express route connectivity. It supports outbound through port 443. There is no inbound, and that way your topology is secure for your InfoSec teams. And then finally, the key thing to note here is, like, from a compliance perspective, if you are thinking about moving data from one region in Australia to another region in Australia, the data will move in the same geographical region. The command will come maybe based on where you have created your Azure Data Factory. Maybe it can be West US. The command can come from there, but your actual data will not leave the geographical boundaries if you don't want to. So now that we talked about data ingestion, we'll talk about data cleansing and data transformation. And for that, as you noticed, if we go back to the chart, we started the data ingestion through Azure Data Factory, the whole end-to-end orchestration. And now we'll go to the analysis part, which is where your data scientists have created these notebooks with some machine learning model or some graph analysis, some deep learning for oil and exploration, et cetera. And now you want to use that transformation activity in your whole end-to-end data pipeline, which introduces us to Azure Databricks. And so far, what we talked about was mostly a batch scenario where data is available, let's say weekly, daily, or some basis. But you also have a real-time data that is being streamed in from IoT sensors, like in the case of Chevron, or let's say some other scenarios where you want to make decisions pretty quickly rather than not wait for the batch data. With Azure Databricks, it also handles, based out of Spark, it handles structured streaming. So you can use the same technology for batch as well as streaming. And you can ingest the data through first-party service like Azure Event Hub, Azure HD Insight Kafka, or Azure IoT Hub. And once the data is ingested, you can use Azure Databricks to transform the data. So how many of you here are familiar with Azure Databricks? OK. So Azure Databricks is a first-party, fully managed analytics service on Azure. It is a GA service available since start of this year. And what we have done is the creators of Spark, company called Databricks, who created Spark back 5 years ago, we partnered with them to create this first-party offering of Spark for analytics. And what this provides to your data scientists, data engineers, and business analysts is a unified analytics platform to do data analysis, to do data engineering, and to have business analysts take a look at the results. As a first-party service, you don't have to go through different companies. Rather, you just come to Microsoft to get this service. So you get built through Microsoft. You get support from Microsoft. You get the SLA from Microsoft. As a first-party service, it's very well integrated into the whole Azure ecosystem. For example, if you want to do data ingestion, as you noticed in the demo, you can ingest the data through Azure Data Factory, and you can trigger a notebook activity of Databricks through Azure Data Factory. Or if you want to move data from streaming, you can connect to HD Insight Kafka or Azure Events Hub, and then have the streaming data being used as an input in Azure Databricks for your notebook. Or if you want to move the transformed data to Azure SQL Data Warehouse, you can do that again using Azure Databricks, because there is a native connector from Azure Databricks to Azure SQL Data Warehouse. What that means is, as a first-party service, you get to use, whether your scenario is modern data warehouse or real-time analytics or modern advanced analytics for modern apps, Azure Databricks becomes a very central piece in all this. And because of its integration to you as an end user, it becomes a very seamless experience, so that you just focus on your business logic, and there is no DevOps, and there is no need to manage an infrastructure that is holding this service. One of the key things that is also provides as a first-party service is integration with Azure Active Directory. So for your InfoSec teams who are worrying about, hey, how is the authentication happening? Do I have to create a new identity provider? Do I have to create a local user on that? No. With Azure Databricks, it's already integrated with Azure Active Directory. So you can single sign on to your Azure Databricks notebook with the authentication happening through the default identity provider on Azure, which is Azure Active Directory. And by the way, this is not a single user. This is a multi-user workspace where your data scientists want to collaborate, make some algorithms, do some notebook activity, do some data engineering. All of that they can collaborate by using the same set of resources, same set of notebooks, same set of clusters, and with a right set of access control. So there is authorization built in so that not everyone has access to all the data or to all the management options. So this is what Azure Databricks as a transformation engine helps for your data engineering. So let's take an example. In this case, Lennox, which again has been doing some data analysis. When they move to using Azure Databricks for doing analytics, what would take them 6 hours would now take them less than 14 minutes, that too to process more than 8,000 more records. And this includes not just batch data, but also real-time streaming data, as you would see in this example. So as we talked about the different personas, data engineers, data scientists, and business analysts, these are the 3 different personas that can use Databricks as a notebook for their activity. Now, how is Azure Databricks different from Apache Spark? You have the option to go ahead, run Spark on your on-premises system or anywhere else. What differentiates with Azure Databricks is because we are using the Databricks runtime. As the founders of Spark, Databricks has been continuously adding capabilities which is enterprise-ready, which is optimized for cloud, and which is optimized for your organization's use case of analytics and data engineering. So as an example, if you talk about performance, Azure Databricks compared to Apache open source Spark, it is much, much faster, even 10x or more. We talked about Azure Databricks Delta. That is capability available only with Azure Databricks. We talked about moving data back and forth from Azure Databricks to Azure SQL Data Warehouse. That is yet another capability available with Azure Databricks and not on Apache Spark. We talked about authentication through Azure Active Directory. That, again, is available through Azure Databricks. So all of the different integrations, all of the experiences around the user experience or capabilities of scalability, performance, independent scaling of compute and storage is available on Azure Databricks, which is not what you would find in Azure and Apache Spark. And by the way, being it on Azure, it is fully managed. You don't have to worry about managing the underlying infrastructure. You get the support and the SLA, so your data scientists, your data engineers don't have to worry about managing it themselves. And from an infrastructure perspective, as I talked about, the compute nodes can be auto-scaled. So let's say if you have 2 data engineers or 10 data engineers using the same cluster, depending on the payload on the Databricks cluster, the compute can be auto-scaled independent of the storage. Because as you would noticed in the architecture, your storage is separate, which is your Azure Data Lake or Azure Storage, but your compute or the transformation is Azure Databricks. Since both are independent, both can be independently scaled. So, and in fact, the clusters are ephemeral in nature, so you can even scale down to 1 node, or you can just pause it, or you can just terminate it, or let the cluster to be auto-terminated, so you don't have to worry about paying for the compute if it is not used. If you think about auto-scale of the storage, what most of you know is the compute can be auto-scaled, but as you know, with Spark, with in-memory technology, especially with Azure Databricks, what we do is we take the remote storage, bring it into the local compute, and in the local compute, it uses the local SSDs where the data is cached, so that for your workloads like machine learning or analysis, the data is then used from the local SSDs, so the performance is much, much faster than what you would see with Apache Spark. And by the way, that local SSDs, if it is running out of the capacity, it can automatically scale after a threshold is met. So that's where Azure Databricks brings to you as a data scientist or data engineers in terms of performance and in terms of capability. And of course, we know Spark, if a node goes down, the job is not terminated. The job can be queued up on the next node. And as a managed service, if a node goes down, the other node will come up, or the compute can be scaled. So your job is not terminated. Your job is still guaranteed to run. Now, with Azure Data Factory, Azure Databricks, it's your language, your format, and your data. So as we talked about, you can create a notebook, and that notebook, for those of you who are coming from an analyst background, you can use SQL, or those of you who are coming from a data science background, you can use Spark, you can use Scala, or you can use Python, or you can use R. As we talked about, with Azure Databricks, you can connect to different sources, whether your data is in Cosmos DB, whether your data is in blob storage, whether your data is in Azure SQL Data Warehouse, anywhere or any format it can read. In terms of format, we recommend to use Parquet format because that is what is enhanced for performance reasons. But of course, that does not mean that Databricks does not support other format. If you have data in CSV, if you have data in org format or JSON or text, as we talked about, data engineering is hard. Like there are different formats. So with Azure Databricks, you can use all the formats. Now let's take an example of how Apache Spark deals with corrupt records as it comes in your pipeline. So in this case, let's say there is a JSON data, and there is the second row is corrupt. So in this case, what you can do is you can specify the mode as permissive so that it allows the value to be available in the data frame, but it will create a new column by name corrupt_record, so you can query it later. Or you can provide an option of drop malformed, where you can say, hey, if there is a bad data or corrupt data, don't just look at it, create a data frame without the bad data. Or you can specify fail fast so that if a bad data comes, you just fail the job, fail the execution, or provide an exception so that you can catch it in runtime manner. Now let's take an example of how Apache Spark deals with schema mismatch. So if you have schema, you can tell to Apache Spark, hey, infer the schema. So in this case, if there is again a JSON file, a JSON format data, Spark can infer and that these all values are long. Or if the value changes, it can infer that. But again, all of these inferring the schema requires the files to be opened, so performance goes down. So you can tell Spark that, hey, user can define their own schema, and then Spark can use that schema to infer the data that it comes in. So in this case, I am telling Spark, like, hey, this is the schema, and now show me those values. Now, so far, as we talked about, hey, there is one scenario of batch ETL where data is ingested on a batch manner. But of course, as we know, that it is unacceptable to certain organizations, to certain scenarios, that if it is a batch data, then you don't want to wait to make decisions. Rather, you want to use or make decisions in a real-time manner. And for that, this introduces to the streaming scenario where we talked about that with Azure Databricks, you can use structured streaming to handle the streaming scenario. And that actually brings us to Azure Databricks Delta. How many of you have heard about Delta? OK, so 3 or 4 hands. So we are excited to announce public preview of Azure Databricks Delta. We have been running this in private preview for quite a while, and this is a capability that exists only with Azure Databricks and not with Apache Spark. So what it allows is, if your need is, if you want to get a better performance for a data pipeline and data engineering, if you want to create a robust pipeline, if you want to create a consistent pipeline, if you want to create a simplified pipeline that handles both real-time as well as batch, then the answer to that is Azure Databricks Delta. Now, if we take about the issues, that what you would see is, if you have multiple readers and multiple writers working on the same data set, it may be possible that one writer went ahead and changed the data while a reader is reading the same data set. That data set is not updated. And so the results may be inconsistent with the most updated data. Or it could be possible that, hey, if you are real-time streaming data that is being streamed in, it creates, as you would know, like thousands of small files. And what you would understand is, if there are thousands of small files, it takes time, it incurs I/O to go ahead and read each of those small files. Rather, if it was a single file or a small, larger file, then it will incur a small amount of I/O. If you think about batch and streaming, like you would have to create different logic. How about a model that creates a single model that could be used both for batch as well as for streaming? So this is what Databricks Delta solves. In case of data consistency, it guarantees ACID transactions. So your transactions or write of the data are transactional in nature. Just as you would use in a database, there is a transaction log. Databricks Delta uses a transaction log capability so that all the writes are atomic in nature, and the readers, even if there are multiple readers and multiple writers, they get the transactional data, and the data is consistent. For performance reasons, you all know about the indexing and the partitioning that you can create. With Databricks Delta, you can create additional indexes through which the Databricks technology or Databricks runtime would use these additional statistics to sort out the columns so that you don't have to scan the whole file. Rather, it will scan only those specific columns that you need to query the data. And as a result, since only specific columns are queried and scanned, your performance is much faster. We talked about the streaming technology. With Databricks Delta, the files, the smaller files that are coming in, that can be, again, compacted so that your I/O is not incurred in reading lots of files. Rather, your I/O is incurred only in fewer files, and that way the performance is much faster. And by the way, you can use the same pipeline for your both streaming as well as for batch data. So we talked about these scenarios. It's not about megabytes or gigabytes of data. We are talking about terabytes and petabytes of data. And of course, this is also available without Delta with Azure Databricks. We talked about the low latency streaming scenario where you can use the same pipeline for streaming as well as batch. We talked about how to avoid corrupt and messy data, especially when there are multiple readers and writers. We talked about how do you adapt to schema. Now, one of the capabilities with Delta you would see is, as I showed in the demo, that you can update a record in the same Databricks Delta. Now, you could specify that you can enforce the schema, that if the schema of the near record does not match the schema of the underlying Databricks Delta table, then it will fail the write. Otherwise, you can also provide the option that adapt to the changing schema so that the writes are not failed. So with Databricks Delta, you get that capability. And then lastly, we talked about how faster it is for data analysts and data engineers is to query the data through Databricks Delta technology with the additional indexing and, of course, caching that is available for both Databricks as well as Databricks Delta. So this is an example of an ETL query where you are reading the data from a CSV file. You are reading another source through a JDBC connection, in this case, the PostgreSQL. And then you are doing some transformation. And then finally, you are saving that as a Delta table. Now, for those of you who are just using a regular Spark table, the only change you would do if you have to start using Delta capabilities for a robust simplified pipeline is to specify dot format as Delta, and then your logic can be just ported from regular Spark table to a Databricks table. So we talked about data ingestion. We talked about data transformation through Azure Databricks. Now it brings to the last section of the data analysis and post-processing. So your data analyst who are using SQL or who are using SQL Data Warehouse, now they want to connect to Power BI tools or other visualization tools to query the data, to create some visualization charts, and especially when there are hundreds and more users to query this transformed data. So this is where it brings us to the last stage, which is your Azure SQL Data Warehouse. How many of you here have heard about SQL Data Warehouse or are using SQL Data Warehouse? OK, so 30% maybe. So let's take a look at the architecture. With Azure SQL Data Warehouse, your compute and storage is decoupled. So that way, just like Azure Databricks, your compute and storage is decoupled, you can pause the compute, or the compute can be also scaled so that you don't have to worry about paying for the compute part of the Azure SQL Data Warehouse. So in this case, what you do is you connect to the control node, and with Azure SQL Data Warehouse, which uses the massively parallel processing architecture of a cloud-ready enterprise data warehouse, it distributes that query to the compute node and then fetches the data from a remote storage. With Azure SQL Data Warehouse Generation 2, that we GA'd in April of this year, we have added the capability of intelligent caching. What it does is that instead of always querying the data from remote storage, it will cache the data to the compute node so that your query performance will be even much faster. So if we take a look at this deeper dive of this architecture, what you see here is in the compute node is the NVMe SSDs and the temp DB files and the cache. So let's say your data is in remote storage. It will fetch the data, push it to the compute nodes, and then finally, when you do a T-SQL query, it will query the data from the compute nodes, so it is much faster. And what it uses underlying is the automated tiering of storage. So your hot data is part of the memory, which is, again, 400 GB plus, and that is just with one node. When you have multiple nodes, that capacity gets multiplied by that factor of number of nodes. For your cache layer, it's 1.5 terabytes, and then finally, you have the remote storage. And by automated tiering, what I mean is, if your data access changes, the cache and the memory gets updated based on the most recent data that is being queried. What it underlying uses is the poly-based technology, which is available as part of the compute node. So instead of every node, like single node, creating a single thread, with poly-based, what it allows is, it creates multiple threads which go ahead and load a data from your Azure storage to SQL Data Warehouse in parallel way. So that's where the movement of the data in a SQL Data Warehouse is much, much faster. Now, we talked about moving the data in the demo notebook that we talked about, moving the data from Spark to Data Warehouse. And this is how it works. So you establish a JDBC connection string from your Databricks cluster to your SQL Data Warehouse. So the green one here is the Databricks cluster, and the blue one is the Data Warehouse. With the JDBC connection established, it means it has just authenticated to the Data Warehouse instance. But when you do a dataframe.save, or let's say dataframe.read, what happens is, on the Databricks side, it moves the data or the Spark table in Parquet format to the Azure storage, which is the temporary storage that is used as part of bulk movement of the data. And then on the Data Warehouse side, it uses poly-based, just as we noticed in the previous slide, that is, it uses poly-based to query the whole of the data in a bulk manner. So what it to you as provides as an end user is faster movement of data in a very performant way, without you worrying about moving the data to storage and then querying the data, loading the data from there. Rather, all of this is inbuilt, and this is just an architectural implementation of how it happens behind the scenes when you just run a df.save.format.options and specify a data warehouse JDBC connection string with the format. Now, we talked about the batch part. We are excited to announce another capability, public preview of streaming usage of the same connector. And it will be clear in this slide as we see here. So we talked about static data, which is the batch data. The batch data is available as Spark table, lands in blob storage in Parquet format, and then Data Warehouse loads it in its instance as a Data Warehouse table. Now, when we talk about streaming data, if the data is coming in real time, what happens is the same Databricks you would use to transform the data, and after the data is transformed, you move the data is moved to Azure storage, and then from Azure storage, it then gets loaded in a SQL Data Warehouse. This is, again, an architectural implementation, but to you as an end user, what this means is the connector not only allows to move the data from Databricks to Data Warehouse for batch data, but it also allows movement of the data for real-time streaming data. This is a newer capability that was, again, in private preview. We are launching public preview today. And that means is you can go ahead and have your real-time scenario being transformed to Databricks. And then in a real-time manner, it will get ingested and loaded into a SQL Data Warehouse instance without you worrying about without you worrying about how to think about how to handle streaming data for your business analyst and data analyst. So at last, in terms of the syntax, as we mentioned that it uses the same syntax, and you can use the same model for both your batch as well as real-time use case. So in this case, what we are doing is the connector is available as part of the Databricks runtime, so you don't have to install or configure. As long as you are on Databricks runtime 4.2 and above, you will have the connector built in. So you just specify the format. This is where you provide the JDBC URL for the orchestration. And then you specify a temp directory, which is a part of your Azure blob storage. And then finally, you say that, hey, the credentials that you provided for the storage account in your Spark is also true for your data warehouse, so that your data warehouse can load the data from the blob storage. And then finally, you save the data in your data warehouse table. And if you take a look at the streaming scenario, it's exactly the same syntax where you are specifying the JDBC connection string, the temp directory, and then you specify a checkpoint location where it says, like, as you noticed in the flow, that you have the stream of data that comes in, and then in the stream, once the data is transformed, then you move the data. So this is where you specify the checkpoint location for that part. In terms of the schema, now it's not just the data movement, but also we have added intelligence in this connector. What that means is, if you are to read the table on your Spark, the connector itself can infer the schema in terms of what your table is on the data warehouse side and what is the schema on the Databricks side. And the other intelligence that we have added is, when you create these table on the data warehouse side through Polybase, we take care of automatically creating objects, so you don't have to worry about it. If you are doing column projection, so let's say the example that I gave of scanning a particular column rather than the whole table or the whole file, the same intelligence is available on the connector as well, so it will scan only that particular column. Now, if you do a select star on the Databricks side, it just selects the first 1,000 rows, or if you do a select for, let's say, top 3 rows, the same limits will be pushed down on the connector to SQL Data Warehouse so that the limits are enforced when you query the data. And then finally, if you want to do some debugging in terms of what's going on, how much of data is moved, you can do it through this by specifying tags. So let me show a quick demo towards the end of a real-time streaming scenario of how this is handled. So I go back to my Databricks notebook, and I have connected to a cluster. And now I simulate a streaming data. Now, of course, this streaming data could be through Kafka or Event Hub. Now, in this case, what I'm doing is I'm creating like 1,000 rows per second, and it is creating into partitions. So let's check if this data is stream or not. So I get the answer like, yes, this data is stream. So I go ahead and run this stream in terms of the data frame that was read through the streams that are coming in. And as we see, the stream has started, and then I'm able to now view this continuously changing stream that is being generated every second. And as the stream is coming in, I talked about the connector where in real-time manner, it will push the transformed stream to my data warehouse side. So let's go ahead and display. So you see the stream that is coming in. Now, as I talked about, using the same syntax that I would use for a batch scenario, now I'm using a real-time scenario, and I will go ahead and move the transformed data to my SQL Data Warehouse. So as the stream is coming in, it's being read through Databricks, it's being transformed, and using this connector, now it will start and move that same data to a data warehouse. So it takes, like I have specified a processing time of 30 seconds, so you can specify 15 seconds or however you want it, but this is just an estimate like that I can provide, which is the checkpoint location, like, hey, move these streams every 15 seconds. So in this case, I'm moving it every 30 seconds. And as you see, the stream is being read, and here it will start to move the data to a SQL Data Warehouse. Now let's go back to the last section, which is about demo that we talked about. We are excited to have some announcements on the Databricks side specifically. We saw in the notebook that there is the capability to use Azure Key Vault to store the secrets. So as a collaborative environment with Databricks, you no longer have to keep the secrets in the notebook. Rather, you keep the secrets in Azure Key Vault so that those secrets can be inferred from the Key Vault. We have launched a trial of Azure Databricks, so if you want to just play around with Azure Databricks, it provides with a trial of 14 days just for DBUs. You still have to pay for the VMs. We are growing very rapidly. Since we GA'd, we are now available in 24 plus Azure regions, and we are adding regions every new month. We have launched a public preview of Azure Databricks Delta, so now you could use and create the robust pipeline. And what we have added, as you noticed, that as a first-party service, the authentication happens through Azure Active Directory. Beyond that, certain enterprises and customers reached out to us that, hey, I want to use conditional access capability of Azure Active Directory so I can put some constraints in terms of how the authentication happens so that only users from this network locations can access it. So we have made that capability as generally available. We are also super excited to let you know that you can now deploy your Azure Databricks workspace in your own virtual network. Till now, what we would do is we would create this Databricks workspace, and it can be deployed in a managed VNet. With this capability, you can deploy it in your own virtual network, so you can have some flexibility if you want to do some user-defined routing of the traffic, or if you want to enable things like service endpoint on the storage or other services. And finally, we talked about the streaming connector that we are enabling in public preview. With that, I will give a pause to my nonstop 75 minutes and spend a few minutes for Q&As. And feel free to use the mic if you have any questions so that it's audible for everyone. Yeah, so the question was for the streaming usage of the connector, is it still going through the storage account? Yes, it still goes through the storage account, but the thing that happens is that that storage account is just used for moving of the data, but once the data gets moved or loaded into a SQL Data Warehouse, that data is deleted, temporary data is deleted from the storage account. Yeah, so the question is what is the frequency of the stream? Now, it takes about like 15 seconds. So you can start with 15 seconds to specify your checkpoint locations. And depending on your scenario, if you want to go with 30 seconds, you can go with that as well.
So on your one slide, you had Databricks has the ability to do job automation and pipeline monitoring and all that stuff. Why would I use Azure Data Factory in combination with Databricks and not just have Databricks manage all the pipelines themselves?
Yeah, so the question was you can do scheduling from Databricks notebook directly. Why would I use Data Factory? And the answer is Data Factory, as we noticed, it is not just connecting to Databricks, but it's doing the whole end-to-end pipeline. So you are doing pipeline from data ingestion to transformation to moving the data to a SQL Data Warehouse or to 75 plus connectors. So if you are thinking about scenario where you have so many different sources of data and you want to not just use Databricks, but rather you want to use all these different sources, and you want to continuously let a single pane of glass to monitor for audit, then you would use Data Factory. But if your use case is simple enough that you know that, hey, I just have this storage account where my data source is present, and I just want to schedule a notebook or some activity through that, then you can just use Databricks notebook scheduling workflow.
One question on that.
Yeah.
For SQL data warehousing, is it auto-scaling is available on that for SQL data warehouse?
Can you say that question again?
Auto-scale on SQL data warehouse is available?
No, so today it is not available. You can manually scale it, but I think that capability will come at some point.